Hello everyone, my name is Ataralik Bayaki Mubarak, and today we are going to present about our IoT-based ubiquitous computing system analysis about urban waste management. So first of all, I'm going to present about the introduction and context. Now we are starting from the system overview, which are implementing an IoT-based ubiquitous computing framework for urban waste management to fulfill core UC characteristic by seamlessly connecting physical waste bins to digital monitoring dashboards, and also to utilize embedded sensors to continuously measure waste, distance, and capacity in real time. Also, we are going to move away from inefficient traditional periodic collection schedules toward dynamic context-aware operations. And our current challenges are bins frequently overflow before scheduled pickup dates, and then we have the lack of real-time filling status leads to missed collection. And the third one, having a high greenhouse gas emission from non-optimized truck routes. And the last one, it would be the improper waste disposal in cities creates public health hazard. And for this system, our primary stakeholder will be the system administrator that has the full accessibility on the system, and then the collection staff, which rely on turn-by-turn guidance and real-time for bin notifications. And the last one will be the waste management orgs, utilize historical reporting data to optimize strategic costs.
So I will presenting for part 2, which is architecture and smart TAE. So system description lifecycle. First one is input. HESR 0 volt ultrasonic sensor embedded within the waste bin continuously measure the physical distance to the waste surface. The Node MCU Amiga microcontroller process this raw distance data. And then second is processing. For the Node MCU transmit real-time telemetry via Wi-Fi to the ThinkSpeak cloud platform. And then the system adapt autonomously by shifting collection priorities and triggering local LED visual indicator. The last part is output. The process intelligence drive a comprehensive web monitor dashboard detailing live maps and vehicle routes. It push automated optimal route notification to staff mobile application. Smart day architecture, which is a device layer, edge computing, the hardware foundation relies on the Node MCU Amiga, and then microcontroller with integrated Wi-Fi. Then the environment integration, the architecture bridge multiple operation domain. It connects the physical environment of distributed urban waste bins. And then the architectural synergy, as illustrated in the architectural diagram, the system function across distinct hierarchical layers, data acquisition and device layer flow upward through the communication and management layer. The interaction analysis overview, interaction type, which is a human-computer interaction as administrator and staff navigating dashboard. And then the computer-computer interaction, automated seamless background data exchange between sensors. And then computer physical interaction, ultrasonic sensor measuring the physical distance to waste. And then the last part is human physical interaction, which is collection staff manually interacting with physical beings.
Okay, so my name is Ahmad Al-Afarizmi. So today I'm going to explaining my part regarding UC characteristic. So basically, our system has three main properties that make it a ubiquitous computing system. So the first one is context aware. So the system can read the situation on its own. It checks how full each bin is and where the trucks are, and then adjusts the route by itself. And next is distributed. So meaning it doesn't run in just one place. It works across the bin sensor, the cloud, and the driver app at the same time. And last one, implicit HCI. Staff get alert automatically. They don't have to keep opening the app to check anything. And then for the autonomy part, so yeah, the system can respond on its own when a bin gets too full, and it raises the priority automatically. But we want to be honest, right now it only react, so there is no prediction or machine learning yet. So for it to work properly, so three things really matter. For first, the counting has to be reliable. So and then the update needs to be fast enough to field use. And then the whole architecture need to handle more bins without crashing. And then of course there are some limitation. If the network drops, like the whole thing kind of break. If we push too many alert, the staff will just start ignoring them. And the sensor are outdoor. It's basically get annoyed by the weather and physical stuff and can mess with the readings. So yeah, those are real challenges we're still working around.
Assalamualaikum warahmatullahi wabarakatuh and good day. I want to present about the part 4 evaluation summary. This slide is summarized the strengths and weakness of the aquarium system. The system supports calmness through automatic background monitoring, provides mobility with remote access, and reduce manual inspection work. However, issues still exist such as notification overload, reactive monitoring behavior, and low transparency in route recommendations. Next is smart priority notifications. This improvement introduced smart priority notification. Critical alerts are highlighted, while lower priority alerts are grouped into single summary notifications. This helps reduce notification overload and improve user focus. Next is about the predictive monitoring. The system uses historical data and field level trends to predict a future overflow before it happens. This allows collection staff to plan earlier and work more proactively. And here in the explainable recommendations, user can view factors such as urgency level and travel distance that influence route selections. This helps users better understand and trust the system. In the simplify the dashboard, the interface reduces the visual clutter and highlights critical information more clearly. This improves decision making speed and reduce cognitive load. Last is about the expected benefits and conclusions. In conclusion, this improvement aims to create a more efficient and user-friendly system. The redesign improves calmness and increases transparency and supports proactive waste management operations. I think that's all for me. Thank you. Assalamualaikum warahmatullahi wabarakatuh.